Let's look at this position time graph. We already know that the average velocity in the time interval from 1 second to 2 seconds just equals to the slope of this secant in the time interval from 1 second to 2 seconds. It's because the average velocity equals to the displacement delta d divided by the time interval delta t. And look at the graph. The red line is just delta t, and the blue line is just the displacement delta d. From the graph, we know that delta d divided by delta t equals to the slope of the secant. So the average velocity in a time interval equals to the slope of the secant of that time interval. Now we know the average velocity, but what's the instantaneous velocity at a point? For example, what's the instantaneous velocity at 1 second? What's the instantaneous velocity at 1.5 seconds? What's the instantaneous velocity at 2 seconds? The instantaneous velocity at a time point equals to the slope of the curve at that point. For example, the instantaneous velocity at 1 second equals to the slope of the curve at 1 second. And the instantaneous velocity at 1.5 seconds equals to the slope of the curve at 1.5 seconds. And the instantaneous velocity at 2 seconds equals to the slope of the curve at 2 seconds. We can draw a tangent line of the curve at each point. A tangent of the curve at a given point intersects the curve at that point, and the slope of the tangent line equals to the slope of the curve at that point. For example, this line is the tangent line of the curve at 1.5 seconds, because this line intersects the curve at 1.5 seconds, and the slope of this line equals to the slope of the curve at 1.5 seconds. And because the instantaneous velocity is much more useful than the average velocity, so if we do not specify, when we talk about velocity, we are just talking about instantaneous velocity. And we know that average speed and average velocity are related. Average speed is a scalar, and it only has magnitude. Average speed cannot be less than 0. And average velocity is a vector. It has magnitude and direction. Average velocity can be positive, can be negative, and also can be 0. And average speed can only be positive or be 0. Now, there is instantaneous velocity. There is also instantaneous speed. The instantaneous speed and the instantaneous velocity are related, just like the average speed and average velocity are related. The instantaneous velocity is a vector, and it has magnitude and direction. The instantaneous velocity can be positive, can be negative, can be zero. And instantaneous speed is a scalar. It only has magnitude. And the instantaneous speed can only be positive or be zero. It cannot be negative. It cannot be less than zero. And the instantaneous velocity at a point equals to the slope of the tangent to the position time graph at that point. And the instantaneous speed equals to the magnitude of the slope of the tangent to the position time graph at that point. So the instantaneous speed and the instantaneous velocity are more related than the relation between average speed and average velocity. And the magnitude of instantaneous speed equals to the absolute value of the magnitude of the instantaneous velocity.